That was so random.
Alright, so the very first thing that we're going to talk about is the Sohcahtoa. Okay, so I hoped that most of you guys would remember Sohcahtoa.
Oh no,
I know it's so exciting that you're getting to see everybody again.
so exciting.
I know. I do. After notes. Okay, so we've got the hypotenuse side. Okay, so you guys see my little angle symbol right there? That's an angle symbol. It's like a cursive O with a little like a baby curl, you know, when you draw babies. Okay, so then there's the adjacent side, which is always the one that is next to adjacent. And then the side that is opposite of the angle is called opposite. Shh. Okay, so the SOA, S-O-H, stands for the sine of the angle is equal to the opposite over the hypotenuse. Okay, so this is simply giving you a trigonometric ratio. Something is equal to something else. Okay, one thing that's very important for you to understand is that all of these angles are given in degrees. Okay, there is another way to measure angles, which we will get into, called radians, but for now we are just working within degrees. So it's important that your calculator mode is in degrees when you're doing this. Okay, so just so you know, to check your calculator, okay, you just hit mode, which is up by the blue button. Okay, and it's like the third one down. Okay, if you're on radian, you need to change it. Make sure that it's highlighted in degree mode.
And my answer is wrong.
Huh? No, your answer was okay. Alright, so moving on, what does the Ca stand for? So cosine. So cosine of a given angle is equal to the adjacent over hypotenuse. Okay, what does the TOA stand for? Tangent. So tangent of the angle is opposite over adjacent. Okay, well, there actually happens to be three other trig functions. The inverses of all three of those. Does anybody know what the inverse of the sine function is? No. Okay, so it's it goes like this. It's cosecant. So the reciprocal. Okay, so the reciprocal, if I just flip my opposite over hypotenuse, then the cosecant is the opposite. Nope, sorry, excuse me. My brain didn't flip. CSC. Yep. Excuse me, hypotenuse over opposite. Okay. So they're just reciprocal. So does anybody know the reciprocal function of cosine? Secant, very good. Secant. Okay, secant is abbreviated SEC, secant. You guys want me to write how you say this? So cosecant is cosecant. SEC is secant. Okay, and what is the secant equal to? What is the secant reciprocal? There you go, hypotenuse over adjacent. Anybody know what the reciprocal of tangent? Cotangent, very good. So we say COT for cotangent. Cotangent. So what is cotangent equal to? Adjacent over opposite, very good. Thank you. Okay, so I'm going to give you a couple definitions here really fast. They're going to also give you definitions of reciprocal functions, okay? This is slightly redundant in my opinion. I'm just going to go through this very fast, but just so you understand that they are reciprocals, I already kind of said that. Okay, so reciprocal functions. The reciprocal of sine is cosine, so it would be 1 over cosecant. So therefore cosecant, I have a hard time saying cosecant, it doesn't feel natural to write. So what is cosecant equal to? 1 over sine, good. Okay, so then for cosine, what's the cosine reciprocal?
Wait, so those two go together?
Uh-huh. Well, they're just reciprocals of each other.
Yeah, this isn't making any sense.
I haven't done anything yet, we're just writing definitions. Oh, well, we'll do some examples. I haven't done anything yet. Just write it down. Okay, so cosine, what's the reciprocal of the cosine?
What is that little O?
The secant, right? So 1 over secant, S-E-C. Yep. So what is secant going to equal? 1 over cosine. Okay, what about tangent? What's the tangent going to equal? There you go. 1 over cotangent. So what will cotangent equal? 1 over tangent. Okay, and then the last identity they give to you is that tangent is also equivalent to sine over cosine. And that will come into play later on. I don't think we use this a lot initially, but you will use it later. Okay, so if we know that tangent is sine over cosine, what can we say that cotangent is? Since it's a reciprocal. There you go, good. Okay. Check 1. Everybody got it written down so I can do an example of what we're doing? Why do we have reciprocal? Why? It's a good question.
What am I going to use this in my head?
Other than in Pre Calc class.
Yeah.
Well, you can use Sohcahtoa in your real life if you were solving a triangle, perhaps building a house. Oh. All right, anyways. Okay, so what's going to happen is they're going to potentially give you a triangle that has all 3 sides given. Okay, so they might give you a triangle that only has 2 sides given. How would you find a 3rd side of a right triangle? Okay, so you'd use Pythagorean Theorem to find a 3rd side. Okay, so what they're going to have you do is they're going to have you find the exact values. The angle symbol? Yeah, it's like a circle with like a Little hat. Curly hat.
I think that also oh my gosh, all six of them.
All six. Okay. So all we're going to do, so the first six that we wrote down, the sine, cosine, tangent, and the reciprocals, so cosecant, secant, and cotangent, those are the six. Okay, so all we are doing is simply writing down the ratio that each of the six are equal to. Okay, this is not complicated. Okay, so we have the sine. Okay, so by definition, sine is opposite over hypotenuse. Okay, so if my angle is down there in the bottom, what is my opposite side length? 8 over the hypotenuse, which is 17. Okay, I'm going to go straight to the reciprocal of that. The reciprocal of sine is cosecant. So what would my ratio for cosecant be? 17 over 8. Very good. Okay, so then we can go to cosine. Okay, we're just simply setting up the ratio. What is the ratio for the cosine? 15 over 17. Okay, so the reciprocal of cosine is secant. So what would the secant ratio be? 17/15. Good. Okay, the last one is tangent. So what is tangent ratio? Opposite over adjacent. 8 over 15. Okay, and it's reciprocal? 15 over 8. Everybody follow that? Okay. So that one was pretty simple. Okay, so let's make it a little bit more fun. Okay, so let's say they give us this scenario where they give us a cosine ratio. Okay, so they're giving us the cosine as 2/5, and they ask us to find the other ones. Okay, so I'm going to start this by simply drawing my right triangle and coming up with the third side. Okay, so here's my right triangle. There's going to be my angle. Okay, we know by definition cosine is what over what? You keep saying that. Adjacent over hypotenuse. So, what is the length of my adjacent? 2. And what is my hypotenuse length? 5. Okay, everybody see how I labeled those? Okay, so the side that I'm missing is my opposite. I'm going to call my opposite x for a moment. Okay, and I'm going to solve for it. So how would I solve for the x? I wouldn't use cosine. If I was going to solve for cosine, that would find the angle value, which I'm not looking for. You could, but it would be easier to just use Pythagorean Theorem. Although you could do it that way. That's not wrong. So we would say 2 squared plus x squared is equal to 5 squared. So x squared would equal, let's see, 5 squared is 25. And I'm going to subtract my 2 squared to be 4. Everybody follow that? So can we all agree that x is the square root of 21? Everybody follow that? Okay, can you break the square root of 21? No, so you do leave it like that. Okay, so this ratio is going to have a root in it. Okay, so let's start with the sine. Okay, so sine is opposite over hypotenuse. What's my ratio? Okay, so the square root of 21 over 5. See how I did that? So you just replace the x with the actual value of the x. Okay, so let's do the reciprocal. So the cosecant, what's my cosecant reciprocal going to be? So 5 over the square root of 21. Now can I leave this? You do. Okay, you're going to become very good at quickly doing this. How do I get rid of that square root in the bottom? Just multiply, right? We're going to multiply by the square root of 21. Okay, this is going to quickly become 5 square root of 21 over 21. Everybody good there? Okay, I'm going to write my cosine even though it was given, just because it's habit to write 6 of them. So cosine was given as 2/5. So my reciprocal is the secant. So what's my secant ratio? 5/2. Okay, and then we go to tangent. And tangent is opposite over adjacent. So what's my ratio? The square root of 21 over 2. Okay, so then if I go to my cotangent, I have to flip that. Can anybody go straight to the quick version? Nice. 2 square root of 21 over 21. Is everybody okay with going straight to that? No?
Just one favorite question.
Yes.
Would you ever have to simplify, like if
Ratio?
Like, if it was 22 on the bottom?
Yep.
Then you would like break that down.
And that might even give you something like initially, who knows, let's say you got, I don't know, I can't think of anything. But yeah, potentially the fractions can reduce. All right, that was fun. Everybody good with ratios? Okay, so that's the initial setup. Okay, they're also going to have you solve triangles, okay, which is what Skyla did at the beginning of class today. So using Sohcahtoa, I'll just do a couple of them. So we'll do find the missing side, we'll do a side, and then I'll show you angle, how that's slightly different. Okay, so let's say we have our right triangle, the hypotenuse length is 18, the adjacent is x, and we're given an angle of 42 degrees. Can you see that? How's that? Better. Okay, so initially I have to make a decision. What are the two sides that are involved? So what trig function am I going to use? What's that? Okay, so cosine. So we have adjacent and hypotenuse, so we're using cosine. Okay, so what's my ratio going to be? The cosine of 42 degrees is equal to adjacent over hypotenuse, so it's going to be x over 18. Okay, so when you type that in the calculator, make sure again that your mode is in degrees. You should always double check that anytime you're using your calculator, because we might potentially be using a different mode somewhere else.
So to solve for x,
Yep, and that's exactly the way I would type it. Okay, so I would type in, I'm going to check my mode real quick, cosine, let's see, oh, I'm in radians. Okay, and I would even type the 18 in the front times the cosine of 42. You can still type the 18 in the back, just make sure you end the parenthesis. Okay, so did everybody get 13.38, we'll call it? 13.38? Okay, good.
Wait. How did you figure that out?
I just did 18 times the cosine of 42. Good there? Let's do one with the missing angle. Find So let's say there is our missing angle. We have 16 and 14 as our two sides. Okay, so again, we're just setting that same ratio up. What two sides are involved? Opposite and hypotenuse. So which trig function is opposite and hypotenuse? So sine. So it's going to be the sine of the angle is equal to opposite over hypotenuse, so 14/16. Okay, now this is a little bit different when you type this in the calculator. That's when you use your second. So that's the inverse button that you guys were talking about before. Okay, so I'm going to type in second sine, which is the inverse. Notice that's not the same as the reciprocal. I did say inverse initially. That was my fault. Of 14 divided by 16. Okay, and then it should pop out our angle value. Okay, so this one is 61.04 degrees. Everybody get that number?
Wait, that's how we find the missing angle.
Yep. So you use anytime you're looking for an angle, you use the second tangent or second whatever. So the inverse button. See how it has that -1? That's always looking for an angle. Okay, so everybody good with this?
And you'll only need that. Oh, I see.
Do I need to do any more examples of finding pieces of triangles? All right. All right, so your assignment's on page 227, and you have, hold on, let me double check this. I think that page number is wrong. Oh, shoot, thanks. Okay, so you have 4 through 52, but by 4s. That'll probably be the hard part of the assignment, too.